Hello students, welcome to iTTV. Today we're going to learn immunity. Immunity is the ability of a human body to fight against foreign substances such as pathogens. If the immunity of a child is weak, likely the child will fall sick. But if the immunity of the child is strong, he or she most likely will be in good health. So in today's lesson, let's learn more about immunity. The immune system of the human body involves actions of white blood cells such as phagocytes and lymphocytes. So what is this phagocytes and lymphocytes? Phagocytes are white blood cells that engulf invading pathogens and then kill them. They are part of our natural defense against infection. So phagocytes, what does it do? It engulfs the pathogen. And how does it digest these pathogens? By secreting enzyme and digesting them. And finally, actually absorbing these digested materials. But let's look at the next one, lymphocytes. Lymphocytes. The lymphocytes are cells that recognize and remember pathogens which invade human body. Some lymphocytes produce specific antibodies which kills the pathogen. So here it recognizes the pathogens and secretes antibodies to kill them. Immunity. These white blood cells and organs of the immune system protect the body against diseases caused by pathogens. This protection is called immunity. So therefore, immunity means protection from the white blood cells, and we have learned lymphocyte and phagocytes. And besides that, we also have organs of immune system. So these are the two things that is very important in our body. Immunity is the ability of the body to use antibodies to combat invasion by pathogens. Antibodies are produced when antigen or like foreign bodies or vaccines enter the body. So here we understand a distinct difference between immunity and antibodies. When foreign bodies called antigens such as pathogens or vaccines containing weakened pathogens enter the body, white blood cells or lymphocytes are stimulated to produce antibodies, a type of protein to fight the pathogens. This response is known as immune response. So we have learned immune response. Let's look in a simple diagrammatic way to remember and see what is immune response. An immune response is as follows. Antigen, pathogens or vaccines, stimulates lymphocytes or white blood cells to produce antibodies or protein to fight and kill antigen. Type of immunity. Humans have two types of immunity, known as active and passive immunity. So here it's very important, type of immunity, passive and active immunity. Pay attention to this. What's the difference between active and passive immunity? A person has active immunity when the body is able to produce antibodies to fight infections caused by pathogens. Passive immunity is acquired by the transfer of antibodies from another individual to another as through injection or placental transfer to a fetus. So, inactive immunity is the ability of the body to produce, while passive when we have a foreign substance such as antibody and serum injected into the body. So this is the distinct difference between active and passive. Type of immunity. Active immunity is divided into two. They are natural and artificial. Active immunity occurs when the body is able to fight and overcome infections and diseases. active immunity can happen naturally or artificially through vaccination. Now let's look at passive immunity. Passive immunity occurs when the body is given antibodies. It happens naturally when babies get antibodies from mother through the placenta and milk. It can happen artificially through passive immunization. So even in active immunity, it is divided into two, that is artificial and natural immunity. But even same thing goes for passive immunity, whereby it's divided into two, artificial and natural. So we are going to learn in detail of each. So let's start from active immunity. Let's look at natural active immunity. It is achieved after suffering from a disease. The body produces antibodies which gives a lifelong immunity for a particular disease such as measles, smallpox, and yellow fever. So here we have seen an example of natural active immunity. Examples are like mumps and smallpox, whereby as soon as you receive this infection, you will get the disease, but our body will prepare itself by producing antibodies. In the diagram, we can see a boy that has mumps. He has recovered after a few days. He would probably not get mumps again because he has acquired natural active immunity. So this is how we get this natural active immunity, whereby our body knows when it comes for the second infection. So next we are going to learn on artificial active immunity. Artificial active immunity. It is obtained through vaccination. A vaccine is a suspension contained dead or weakened pathogens. Vaccine is given to a healthy person and may last for a period of time. So here, artificial active immunity is actually through vaccination. Now what is the meaning of vaccine? It's actually a dead or weakened pathogens. These pathogens actually enter our body, whereby our body will prepare itself to produce antibodies. So this is how we actually make our body to recognize this pathogen. But what happens? Is it first injection is good enough? Let's see. Normally, more than one vaccination is required before a person can achieve an effective level of immunity as shown in graph below. Example, vaccination against rubella virus, BCG vaccine for tuberculosis. So here we understand one injection is not enough. It actually requires a second injection in order to come to a level. This level is called immunity level, as how you can see in the graph. So therefore, the graph is very important to see how the level of immunity in our body. So you can see the graph goes by for the first one, but the second injection actually makes the graph move above to the level of this immunity level. Natural passive immunity. Natural passive immunity is achieved when a fetus receives antibodies from the mother during pregnancy or through the mother's milk. Artificial passive immunity. Acquired when a sick person is inoculated with antiserum, which contains antibodies to fight against a disease immediately. It is not permanent or last long. Antiserum is prepared from animals which are subsequently recovered from an infected disease. Subsequent injections are given if the patient does not recover. So artificial passive immunity. First injection is actually given to the patient, but if the patient actually doesn't recover, second injection is actually placed into the patient. So this is how the graphs look like, and you have to pay attention and realize the difference of the graphs. Here is a simple summary about the immunity. As we know, immunity is divided into two, active and passive immunity. Let's start from active immunity. Active is divided into two, that is natural and acquired immunity. Let's start from natural. Natural, whereby body produces antibodies when infected with a specific disease, while for acquired, body produces antibodies in response to the vaccine given. Now let's look at passive immunity, and starting from natural, passive immunity. Body receives antibodies from the mother during the fetal stage or from mother's milk. Moving on, acquired is whereby body receives serum containing antibodies or antitoxin. So here we have seen a simple summary, the difference between active and passive immunity. Now let's look at the similarities between active and passive immunity. Active and passive immunities have several similarities and differences. Occurs naturally or artificially. Provides specific protection against specific pathogens. And finally, both involve antibodies. So these are the simple similarities between active and passive. Now let's move on to the difference of these two. Here are some differences between active immunities and passive immunities. Purpose of active immunity is to prevent diseases permanently or temporarily, while the purpose of passive immunity is to treat disease immediately. Period of immunity for active immunities is long-term or permanent, while the period of immunity for passive immunities is short and temporary. The people involved for active immunities are healthy people, while for passive immunities it is infected or sick people. Substances injected into the body in active immunities are vaccines containing dead or weakened pathogens, while in passive immunities, antiserum containing antibodies. Now we have seen a simple difference between these two. Let's learn more. Immunity after injection for active immunities is slow response, while for passive immunity is an immediate response. Reaction of the body after injection in active immunities, where white blood cells are stimulated to produce antibodies, while for passive immunities has no reaction. Example of natural immunity in active immunities occurs after recovery from diseases, while for passive immunities occurs when antibodies from mother goes to baby through placenta and milk. Examples of artificial immunity in active immunities are vaccination for polio, while for passive immunity is antiserum for tetanus. We have seen the similarities and differences of these active and passive immunities. Let's summarize again about these passive and active immunities in a simple table. Immunity. Active immunity has two types of immunity: natural immunity and artificial immunity. Natural immunity is when a person recovers from a disease. He is said to be immune to the disease because the antibody level in his blood is still high. Artificial immunity, where acquired by a person through vaccination, a vaccine contains weakened or dead pathogens that will stimulate the body to produce antibodies. Passive immunity has two types of immunity, where natural immunity and artificial immunity. For natural immunity, it is acquired by a fetus from the placenta or acquired by babies through breastfeeding. Artificial immunity is acquired by a person through injection of an antiserum which contains antibodies extracted from animals, whereby this type of immunity is only temporary. So we have seen in detail the differences between artificial and passive immunity. Now let's learn more about ways to treat diseases. We can treat diseases caused by microorganisms using modern treatment. Let's look at modern treatment. Modern treatment includes the use of antibiotics, antiserum, antifungal drugs, synthetic drugs, surgery, and radiotherapy. So let's start from antibiotic. Antibiotics are chemical substances produced by microorganisms such as bacteria and fungi. These substances destroy or inhibit the growth of harmful bacteria. Antibiotics can only be used to treat diseases caused by bacteria and fungi. Penicillin and streptomycin are two most commonly used antibiotics. So we have learned in detail about antibiotics. Let's look at antiserum. It is normally extracted from the horse blood. Let's look at the preparation of antiserum. A horse is injected with weakened bacteria or viruses of a certain disease. White blood cells called lymphocytes in the horse blood will produce antibodies. These antibodies will attack the bacteria or viruses. The blood sample is retrieved from the horse. Then the blood sample will go through a process to separate plasma from the blood. The plasma is then used to prepare an antiserum. Antiserum is injected into a patient to treat the disease in a short time. So we have learned in detail how antiserum is produced and how it is injected in our body. It all originates from the horse blood. Now let's move on to antifungal drugs. Ringworm is a fungal skin infection caused by fungi. Athlete's foot is an example of fungal skin infection. This infection can be treated using antifungal drugs. Antifungal drugs kills fungi. So here we understand antifungal drugs is to kill fungi. Synthetic drugs. Synthetic drugs are non-organic artificially produced substances. These drugs are synthesized in the laboratory. For instance, malaria patients can be treated using quinine. The quinine is extracted from the bark of the tree and is synthesized to become alkaloid quinine. So here we have seen on synthetic drug, and finally let's look at the last one, that is radiotherapy. Radiotherapy is another method to treat diseases caused by microorganisms. It is a treatment that uses radiation. Radiation kills cancerous cells. For example, liver cancer caused by hepatitis B viruses can be treated using radiotherapy. So here we have learned about passive and active immunity. What is immunization? What is immunity? And a lot of things. On top of that, we have learned modern treatments. Let's look at a simple question. Mumps is a viral infection. A person who has had mumps will usually never get it again. What type of immunity has the person developed? A. Natural active immunity. B. Natural passive immunity. C. Artificial active immunity. D. Artificial passive immunity. So here, first of all, we have to understand is a type of active immunity, and it happens naturally. So therefore, the answer for this question is A, natural active immunity. Let's move on to question 2. What is immunity? A, the body's ability to produce white blood cells to help pathogens multiply. B, the body's ability to produce antibodies to help pathogens remain active. C, the body's ability to produce antibodies and white blood cells to fight other body organs. D, the body's ability to produce antibodies to inactivate pathogens. So immunity, very obvious in this question, the answer is D. The body's ability to produce antibodies to inactivate pathogens. Let's see the next question, number 3. W, X, Y, and Z are steps to prepare serum from a horse. W. The body of the horse produces antibodies for a particular disease. X. The horse blood is centrifuged to obtain the serum. Y. The horse is injected with microorganisms of a particular disease. Z. The horse's blood is extracted. Which of the following is the correct sequence of the steps? A. W. Y. X. Z. B. W. Y. Z. X. C. Y. W. X. Z. And D. Y. W. Z. X. Let's look at the order. First, the horse has to be injected with this pathogen or the microorganisms. So therefore, Y starts first. Secondly, the body of the horse actually produces this antibody inside. So the answer would be W, the next one. Number 3 would be the horse blood is extracted. Then finally, the extracted blood actually will go through a centrifuge process to obtain the serum. So therefore, the answer for this question would be D. So let's summarize what we have learned today. We have learned white blood cells is divided into two, that is phagocytes and lymphocytes. On top of that, we have learned immunity, whereby it is divided into two, active immunity and passive immunity. We also have learned that this passive immunity can be divided into two, that is natural and artificial immunity. On top of that, we also learned active immunity also can be divided into two, that is natural and artificial immunity. We also have learned the different types of modern treatments in our era. In this modern treatment, we have learned a lot of types, whereby antibiotic, antiserum, antifungal drugs, synthetic drugs, and radiotherapy. I will see you in the next lesson. Thank you for watching iTTV. Goodbye, students.